Okay, we are now going to go on to finding the perimeter and the area of a triangle. So again, for the perimeter, we have to make sure that we have all the side lengths. We really like when there's a vertical and a horizontal line that we can just count. So I'm just going to count for EF. I've got 1, 2, 3, 4, 5, 6, 7. EG, I will have to use the distance formula or the Pythagorean theorem. So I'm going to go ahead and I'm going to use the distance formula as directed. So point E, the coordinates for point E are 2, 9, and the coordinates for point G are, let's see, looks like 10, 2. Okay, so this is for EG. I'm going to go back real quick. I hope this doesn't confuse you, but FG I can go ahead and count too. So 1, 2, 3, 4, 5, 6, 7, 8. All right, now back to my distance formula. So it doesn't matter which one you choose is x1, y1, which one's x2, y2. And I can go ahead and start just substituting into my distance formula. It's going to be 10 minus 2 squared plus 2 minus 9 squared. That'll end up being equal to 8 squared plus negative 7 squared, okay, equals 64 plus 49, which equals the square root of 113. Ooh. Square root of 113. The square root of 113 is 10.6. 10.6 now is going to be, it's not square root, equals 10.6 is EG. So for the perimeter, I add up all my side lengths. So I just add up 7 plus 8 plus 10.6. That'll give me 25.6. And that's my perimeter. Check for units. I don't see any units here, so I'm just going to write units. For the area of a triangle, it's 1/2 base times height. So the base is this bottom piece here, and the height is going to be this vertical piece right here. Well, we already have those distances, so we have 1/2 times 7 times 8, which ultimately equals 7 times 8 we know is 56 times 1/2 is 28. And again, we don't have any units here, so I'm just going to write them as units squared. Okay, area is always units squared. All right, moving on to this next question. I have what is the perimeter and area of a square if the coordinates of one of the sides is 0, 0, and 3, 0. So 0, 0, and 3, 0. So it doesn't matter where you put your square. The thing that you have to know is that all sides of a square are the same. So if all sides of the square are the same, then my square length is going to be 3. No matter if it's down this way, no matter if it's up this way, it's going to be a 3 by 3 square. So the area of a square is equal to the side squared. If I know the side is a length of 3, that means the area is 3 times 3, or 3 squared. And that's going to give me 9 units squared. Again, pay attention to making sure that you're having those units on there. All right, one last one that I want to go over is finding the perimeter and the area when you're given something that doesn't quite look like a right triangle. It isn't so easy to find the length and the height of your triangle. So the perimeter first, I've got 2 diagonal side lengths. So I have to use either the Pythagorean theorem or the distance formula to find those lengths. So I'm going to label this as 1, this is 2. So for length 1, this time I'm going to use the Pythagorean theorem. So this distance up the vertical is 3, 2. So I have for length 1, 3 squared plus 2 squared equals c squared, and that's going to be that length of that left-hand side. So 9 plus 4 equals c squared, 13 equals c squared, so c is equal to square root both sides, the square root of 13. Oh, hold on. All right, so the square root of 13 is equal to 3.6. So that means that this length right here is equal to 3.6. And I'm going to do the same thing for the right-hand side that I labeled number 2. I'm going to change the color. So number 2 is going to be, again, 2 and 3. We've already done this one before, so 2 squared plus 3 squared equals c squared. It's the same work, so I get that c is also equal to 3.6. Okay, so for the perimeter, all I have to do is add up all my sides. I have 1, 2, 3, 4 is this bottom piece, so it's going to be 4 plus 3.6 plus 3.6. That perimeter is, plugging into my calculator real quick, 11.2. Okay, so 11.2 units. Now for area, we have to do something a little bit different because we don't just have the height. Now I know it's easy to count the height for this one. Obviously the height is 3. But I want to show you something called the box method, and especially because I want you to try the next one on your own. So the box method means that I'm going to take the area of the total box and I'm going to subtract out these little triangles that I have. And there could be 2, 3 triangles. If you have a pentagon, you could have up to 5. And you're going to subtract and you're going to kind of find the area within the box. So for this one, I've got the length already. And I know that my area of my box is length times width. So the box, the height is 3 and the width is 4. So the area of the entire box, the entire thing within, let's see if I can draw that for you, is 12 units. So it's not 12 units because I want the area of the triangle inside. And I've got 2 triangles within that box. So triangle, I'm going to call this triangle A. And I'm going to subtract out that area of triangle A. Well, the area of a triangle is 1/2 base times height. And the base of my first triangle is 2. So 1/2 times. And the height is going to be 3. So half of 2 times 3 is 3. So 2 times 3 is 6, times 1/2 is 3 units. So that's this green triangle up top. Okay, so now I'm going to have the orange triangle is going to be the one on the right. Okay, and again, the area of the triangle is 1/2 base times height. The base of this is 2. The height is 3. So again, this is an easier problem because the triangles are actually the same. So that's 3 units. And if I wanted to find the area of the triangle, the blue triangle inside, which is what I want, I'm going to take the area of the box minus the area of the first triangle minus the area of the second triangle, which is 12 minus 3, which is 6 units squared. All of these are area, so they're actually all units squared. Okay, so 6 is what I actually wanted to solve for. I find the area of the entire box, and I subtract out the area of the triangle. So what I want you to do now is pause your video, and I want you to look at this question and attempt to solve it on your own. And when you're ready to come back in, I'm going to show you what the lengths I calculated were, as well as what the area of each individual piece I calculated in the total area. So pause now, give it a try. Okay, so you'll see that I calculated the length of AB, BC, and AC, added those all together in order to find the perimeter. And then I used the box method. I found the box area to be 35, and I subtracted each of the triangles that I calculated. So those red numbers are all the areas of triangle 1, which is the bottom left, triangle 2, which is the top left, and triangle 3, which is that skinny little triangle on the right-hand side. So you subtract the area of the box, and you should have gotten 15 units squared. And on your task, you're going to be doing something similar. You're going to have your water slides, and I'm going to create my box, which just is a bunch of right triangles, so it shouldn't be too hard to calculate the area of. And now I've got an area of the box. Area of the box. Oh my gosh, I just did the same thing. Area of the box minus, it's going to be the area of triangle 1 minus the area of triangle 2 minus the area of triangle 3 minus the area of triangle 4, and that's going to give you the inside area of what you're actually trying to solve. So I'm not going to solve this one, but this is what you're going to be doing when you're working on your project. You're going to be finding the box area and subtracting out the triangles that you don't want in there. All right, good luck working on task 2. Let me know if you have any questions.